So what, why, and how, like what exactly this buzzword Kubernetes is all about, and why on earth someone need that, and how are we going to use that? So first thing, what exactly Kubernetes is. Now, if in the olden days applications, we usually build an application and we deploy it on a cloud. That's how the typical infrastructure or DevOps works back in those days. Now, all the major big gas companies are being migrating to this thing called containerized applications. So when an application is containerized, it needs to be orchestrated. And for orchestrating, there are several tools, and Kubernetes is one of the tools which sit on top of the chaos when it comes to orchestrations. So what exactly Kubernetes is? It is an orchestrator tool. Again, we have no clue about what are things we are going to orchestrate. I mean, we don't even know what orchestration is. Just go with the flow. Kubernetes is for orchestration, exclusively for containerized applications. So Chandra, do you aware of the normal deployment, right?
Right. Yep.
Exactly. So normally we use GCP, AWS, Azure. We build some
Mhm.
app, be it Java or Python, and then we deploy it on the appropriate services. If it is supposed to be AWS, we would use Beanstalk, or GCP does have the compute engine, where we go, and instead of running things on the local machine, we would run it on the cloud, and from that we have to expose all the ports and things can get be accessible to the whole world. Now that is old typical way. Recent times, all the companies have been migrated to this thing called containerization. So we need to know about two things. One, what exactly containerization is, and what is orchestration is. So in general, music orchestration. So at the end of the day, orchestration in musical is where you be having a huge set of people set over there. You have to give the notes to appropriate musicians, and they will do the work for you. So you, as a musician, can orchestrate it. So similar to that, Kubernetes will orchestrate all these things for us. Let's see how we are going to do that. So what exactly orchestration? So like I said, when I'm saying orchestrations, we need to be aware of this thing called containerized applications. So what exactly a container is? So simple. If you go on, yeah, hello,
Yeah, yeah, I can hear you.
yeah, okay, fine. So simple. At the end of the day, instead of having a code base on a local machine, or be it on an instance on a cloud, we are going to bundle it. So for bundling this, we need to know about this technology called Docker. So at the end of the day, all these orchestrations, orchestrated tools like Docker Compose, Kubernetes, Docker Swarm, Docker Stack are relied on this tool called Docker. So the traditional way of shipping applications to the deployment production environment is by normal code base, SSH clone or GitHub clone would do the work for us. Instead of that, we are going to bundle that. Let me put it in layman's term. Consider you are moving to a new house for the scenario, and you need some packers and movers to do the work for you. So the normal way of doing this is still in rural areas, they hire some local guys where they do all the works instead of these packers and movers. So in these packers and movers guys would have package all those things into separate things or containers or anything, and then they will deploy it to the new house. So Kubernetes is an orchestration tool. What exactly an orchestration is? We need to orchestrate a containerized tool, a containerized web application. What exactly a containerized application is? Instead of a normal code base, we are going to bundle it. That's all simple. No, fancy definitions for what is a container or Docker and stuff. So everything in Docker is an image. So first things first, we need to know about what exactly an image is. So now somehow we are aware of what is Kubernetes is for orchestration. And again, for orchestration, we need to do it with the containerized applications. And when I'm saying container, we need to be aware of this tool called Docker, and everything in Docker is an image. That let's connect the flow like this. So how to containerize using Docker? So this is where Docker comes into the picture. These packers and movers guys will be your Docker. So instead of normally doing this thing, we are going to hire a guy, and they will pack all our web applications or source code and deploy it in a new. Hello?
Yeah, yeah, I can hear you. Yep, go ahead.
Okay, okay, sure. So we need to know aware of this tool called Docker. So what exactly a normal web application versus a containerized application is? So right now we are aware of three terms. One, it is Kubernetes, and when I'm saying when we need to use Kubernetes, we need to orchestrate web apps at the end of the day, and orchestrated needs a containerized applications. So before diving into containerized applications, we need to know about what exactly differentiate containerized applications with the normal web applications. So the first one is a hand pulled rickshaw, right? The second one
Mm-hmm.
is a horse. So a normal web application is the one which where we need to manually do. We need to do all the works. Like once we deploy things, we need to do the health check. We need to expose the ports. We need to make sure healing factors are happening correctly or not. Whereas in case of containerized applications, the horse will do the work for us. So here again, instead of doing a manual pulling, we are using a horse to pull the carrot. So,
Okay.
and again, when I'm saying people don't use containers applications when you don't have much of a necessity, just because of buzzword, they can't implement. I've been getting some of the freelance gigs where they ask me to migrate their entire web applications to Kubernetes, but they don't have enough resource for that. Having two microservices and then using a Kubernetes is like you are hiring a guy like how to say, a guy like AR Rahman and then ask him to sing in a local stage. So it won't work that way. So
Okay.
when you are using a powerful tool like Kubernetes, you need to have that type of complex architecture on your web application. So containerized applications are exclusively for complex microservices. Okay, so this is one example of using one horse, but we won't usually use one horse to pull our carrot. We're going if we are going to have a chaotic applications where take these dog shells. So all these dogs are considered as a microservices. I mean, suppose we are having one web app and it does have 10 plus microservices. Now we need a perfect way to organize these things so that we could ride along without much chaos. So companies like Netflix, while they've been doing, if you take Netflix, they would be having thousands of microservices for each and everything. They can't manually pull all these things, and it would be a complete mess. So that's why they've been relying on a tool like Kubernetes. And while we are picking up a tool like Kubernetes, the applications architecture at least have to be a little bit complex instead of normal one. I know when you are having a landing page, and you can't use a Kubernetes for landing page just because of the buzzword, and everyone is using it
Mm-hmm.
exclusively for microservices at the end of the day. So right now we are aware of four things. One is Docker, one is Kubernetes, one is containerized applications. And when it comes to containerized applications, we need to be aware of this thing called image. So like we saw earlier, we need to package all our code base into a pack. So for packing that, the package and movers guys will do the work for us, which is the Docker tool.
Mm-hmm.
So to build an image, we need to take our code base and then we have to build it using this tool called Docker. So again, Docker is one huge topic which we will be seeing in the next class, but don't get things complicated. For image, we need a base image. So this could be of any base image. Okay, so when I'm saying base image, let's see what would be the necessity behind that. And it can have many layers. Okay, a containers would be relied on image. An image would be having two things. One is a base image with many layers. So base image. So suppose you are using a Java web application. So while building our image, while packaging our things, we need to have the appropriate things that could be relied on Java. So the base image should be Java, and based on that, all the supporting layers. When I'm saying supporting layers, at the end of the day, we would be having one file for Dockerized our for containerizing applications. So while creating the Docker file, we need one base image, and that base image would be based on our project necessity. Suppose our code base is in Python, then we need a Python base image, and then we have to install certain things right at the end of the day. If you're using Java, then you have to install certain libraries. If you're using Python, then you have to install certain libraries. If you're using some front end service, definitely you have to install something. So pick up your programming as a base image and then install things. So what if I don't have a microservices based architecture, I'm having both the backend and front end on the same image. Again, in that case, you can use Ubuntu as your base image, which is an OS, and Windows as a base image as an OS. So this is literally like back in those days, we manually install one more OS on virtual machine, right? Virtual box instead of a machine. Excuse me. So instead of that, we would be install this OS or install this programming language on a separate virtual environment inside our local machine, and that technology is called Docker. So Chandra, are we clear what Docker is about?
Yeah, I understand what Docker is, and I also have an idea
Perfect.
on Kubernetes orchestration part, right?
Okay.
Um, so can we see a practical example where
Yeah, yeah,
we
sure,
can?
sure, sure. Yeah. So right now we need, since you're aware of Docker Hub, I don't want to. So I'm having one code base here. Okay, so I'm going to build this sample image called Python Flask Docker Hello World. So this does have one Flask application. So inside the Flask application, are you aware of Python web services, Chandra?
Yeah, I mean, I'm aware of web services, and I'm aware of little bit of
Perfect.
Python. But
Okay.
so
That's fine.
what is?
Then you can keep up with the flow. Then. So
Yeah.
what I'm having here at the end of the day is I've been using this framework called Flask, which is a Python framework,
Mm-hmm,
and this can be used to do write exclusively web services.
mm-hmm.
So in typical way, we would be having this code base app.py, and then we will deploy this app.py on cloud. Now
Okay.
I'm going to pack this code base at the end of the day so that I can ship it to any cloud or any environment, be it on premise, without having that machine's dependency. So this is going to be a separate environment. So
Okay.
to package this,
Yeah,
yeah,
can I ask you one question here? So your
yeah,
Flask application is taken from the Docker.
exactly, yes.
So you took the Flask application, which basically has everything underneath it, along with the Hello World program coded in there.
Yeah, yeah, yes,
Okay.
yeah. This is just a
Right.
normal application with one view where if we run this server and add slash at the end, it would throw this run Flask is running inside Docker. This is like
Right.
a simple app that you will.
Right. So if I need a Docker image for my application, right?
Yeah, yeah.
Say in this case, if I'm a novice user who says, "Hey, I'm coding an application in Java," instead of
Okay,
Flask, I'll say, "Hey, in Java, I have a Spring framework, and
okay,
then I'm writing a program called Welcome Siddharth." Okay, right?
okay. Yeah,
So my Docker image is built using the JDK, using like the basic whatever operating system piece
yeah,
with the JDK, like
yeah.
maybe on a Red Hat Linux with the JDK, and above JDK with Spring framework, and above that my code, all containers. and put it in a Docker image.
Exactly. Yes. Yes.
And
So we are
and that
bundling
doc
all. Yeah.
Mhm. So that Docker image, now you're showing me how to um how to
Exactly. Yes.
orchestrate using Kubernetes. Okay.
Yes. 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 Yeah. So if you are if in case of mobile developers, be it Android or iOS, at the end of the day, they will bundle all their code base into .apk extension for Android or I'm not sure about Apple's version. So they will
Hmm.
bundle their code base, right, instead of a web application. We don't have a
Hmm.
necessity for web application to bundle it. But again, we've been adhering to that way of deploying our applications. So we are bundling our entire code base and putting it into a single image at the end of the day. Yes, you are right.
Okay.
So now, like I said, at the end of the day, we would be having this file called Docker file. And the moment you add a Docker file and do certain commands with it, your application would become a containerized application. So what are things we need to do? One thing is we need to build the image. So for building an image, we have to be aware of certain Docker commands. One of the command is Docker build -t, your image name, colon, your tag name,
Hmm.
space dot. So the dot here indicates what this command exactly doing is, the moment I run this command, it will look for Docker file.
In the
So
current folder, right?
yeah, exactly. In Linux, while we add dot, it will look for the current folder. So you have to be aware that while you are running this command, you need to be inside the code base which contains the Docker file. So you have to be at that source.
Hmm.
So an image name is, again, while you are bundling something, they are giving an image for it. And this image would be used across all the entire web applications, and you can have separate tag name. So if you are having several versions for your web application, you need, each web application needs to be put it on a separate buckets on AWS with different version name. Then we can use tag names like Docker build -t, my hello world app colon version 1, and then version 2. So this is having same name at the bucket and categorized into separate versions.
Okay.
And then yeah, so this is how this command is all about: your image name of the image, and then your release version 1, version 2. So let's build a Flask Docker image and run it. So first thing is I need to convert this thing to a Docker image. So for that, I need to be aware of this command: Docker build -t, your image name colon tag name space dot. So my Docker file is here. Let me walk through the Docker file itself.
So you already have Docker on your machine and then Kubernetes also on your machine.
Yeah,
Is that
yeah, Kubernetes we can't directly install. Kubernetes is like a huge tool. We will see about that, how we can hands on a local mission.
okay? But you have
So
Docker on your machine.
yeah, yes, sir, I do have Docker. Okay, you have to install Docker. Um, and then you have to build this Docker file. Uh, Let me go inside this Docker file first. So this is our application. This is just a simple, just 7 lines of codes with a Python Flask application. I'm going to containerize this. So like I said, well, if you want to containerize your application, you need to have this file called Docker file. So inside this is our base image. Rest of the things are installation steps. So these things are, at the end of the day, certain definitions that Docker has built in with it. Copy is one command. Workday is one command. Run is one command. Expose is one command. I have to use 5000. I have to comment this out. Okay, so these from copy, workday, run, entry point, CMD, all these things are Docker definitions. Each
Okay.
and everything have separate purpose for that. say from Python 3.6. So what I'm saying here is, hey, consider this as my base image because the code base which I'm having is relying on Python 3.6. So what you have to do is, so at the end of the day, this will go to Docker Hub. At the end of the day, this will go to Docker Hub. So this Docker Hub is like a Play Store for all the Docker images, where all the images will be there. So instead of installing Ubuntu on our local machine, we can use Ubuntu base image. It is already here. Instead of installing a Redis database on our local, we can make use of Redis base image and we can build things on top of it. So this is like a Play Store for all the applications. Node.js is here, Postgres, MySQL. So I don't even need to install these tools on my local machine. So in that case, I can achieve, suppose I'm having 5 applications. Okay. So one application is using MySQL version 12.1. And then one more application is using Postgres 10.1. And then one more application is using Postgres 13.1. It is a pure nightmare if I need to install or reinstall all these things, right, on my local machine. So instead of doing that, I can containerize my application. Then I can use the appropriate version of database that needs to be run as a part of the web application, and that will do the work for me. I don't need to bother about installing or reinstall all these things on a local machine. So that's one of the major impact of having Docker on your web application. So all the things will be happen as a separate environment instead of bothering your local environment.
So
So
basically, so you take the base images from the Docker, right?
Exactly, yes.
But you can also build your image from you can
Exactly,
also
we
build
can.
your own image, right? So let's say if I have a you know if I have my own software, for example, like something like a MuleSoft or web methods, right? So I get their microservice runtime, right?
Okay.
And then get the Red Hat um, base, mm, operating system kind of like meant for the containerization, and then actually build them together, right?
Exactly, yes. Like I said, since it is a Play Store, if you see, not all the Docker images are official one. These things are official images.
Mm-hmm.
Out of all these 9 lakh things, very few are official image. Rest of the images were developers like us customize it and push it over there instead of having it on the local machine. Yes, like you said, you can build your own image. So if you see, there is one guy who is the creator of Fast API. He had customized image for Fast API, where we can make use of it straight away. Like you said, yes, we can do that.
Okay.
What I'm saying here is, so from Python 3.6, and then use this Docker definition called copy. So dot is Linux representation to take whatever things which is on the current environment, which is this directory, and then put these app.py inside a directory called app. Now this app directory wouldn't be inside my local machine. It will be inside the Docker environment.
Mm-hmm.
You can't see it. You got that perspective, right?
Yeah.
Yeah. I'm virtually creating a directory inside my machine, but I can't access it unless my image is running, so that I can go inside it and check the created directory.
Yeah.
Now, this definition is, if you are using Python, then you might have aware of this tool called pip.
Mm-hmm.
Pip is responsible for installing packages.
Yeah.
Pip install, it's like the sudo apt for Linux.
Mm-hmm.
So inside the requirement.txt, since my application is relying on Flask, you can have n number of definitions over here. Suppose you are having Django based requirements, then you can do Django or it's again, it depends on your web applications.
Right.
So
Whatever is required for your application to run.
exactly, what are the packages that needed? The Pythonic way of defining requirements for a package is, we usually create requirement.txt file, and then we have to put all the necessary dependencies inside it. Now, to run inside our local machine, someone has to do this pip install -r, and then running this txt file. So the moment they do this, it will look for requirement.txt file where the command is has been run, or if it's not there, it will throw one built-in exception. So if it is there, what it will do is it will go inside it, and instead of manually installing all the dependencies one by one, pip install my first package, pip install my second package, it will install all the definitions that has been inside of the requirement.txt file. So I am automating this work inside my container here. You got the perspective here, right?
Yeah, yeah.
Yeah. So I'm not going to install this on my local machine. So what I'm saying here is, hey, take a Python image, create a directory called app, and what you have to do is, there are some files, some Python files here. Put it inside this temporary directory. Now, I have certain definitions on the requirement.txt file, which I usually install on my local machine with pip install -r requirement.txt. Now, what you're gonna do is install these things for me on your environment, so that I don't need to bother about these packages on my local machine. An entry point is one command, which is like, if you want to run this Python file, then you have to use Python app.py on a terminal, right? So entry point is the first command that needs to be defined as a part of running this application. So I'm saying, for entry point, keep Python, and then for the command, run app.py. This cmd can have any definitions along with it. Like suppose you are saying you need to define a host, you need to define a port, then those type of definitions will be come over here. So these things are not Docker based customization. These things are Python's based customization. You got it, right?
Yeah.
These run entry point cmd or Docker definitions. The rest of the customization on the right hand side they're doing are Python based ones. So we need to build this image. Let me build this image. So I have installed Docker, so I have to use Docker build -t. I want to give this image a name, so I'm going to give this first demo, first Flash app, and then dot. So now my code base will be packaged into an image. Okay, showing another account, add files. Let me do one thing. Let me start from Minikube. I believe both the Kubernetes API and Docker API has some mismatch.
So what is Minikube?
Yeah, we will see about that. Minikube is like a toy, like I said. So while using a
That's
tool
for
like, yeah, yes, go ahead. Yeah. Hello.
yeah. It's a Kubernetes, right?
Yeah. This is actually Kubernetes is one tool which will be available on major cloud providers. So Minikube is like a toy version of it, so that you can play around, like creating clusters, creating deployments and services and load. So let me build this image again. So Docker build empty Flask container image. Perfect. Now my image is built. So the problem is was both the Kubernetes API and the Docker API has been trying to use same port. So now I disabled it. So we don't need to bother about that. I disabled that. Now we can access it. So what we did is we have bundled our entire code base, the app.py requirement.txt, into a single Docker image.
Okay.
So to list out all the images in your local machine, you have to be aware of this command called Docker image ls. So I believe if you're supposed to use Linux, hope you might be aware of ls command, right? This will list out all the directories. So similar to listing out all the images, you have to use Docker image ls. Now let's list out all the image. So this image, which is Flask container image, is here. Now to run this image, we have to aware of the run command. So docker run -p what is my port near 5000 or 5000 colon 5000, and then my image name is Flask container image. Perfect. Now my image is running. Okay, perfect. So instead of normally running the image, I have bundled my code base into a single package. And then what I'm saying here is, hey, there is one image called Flask container image. What you have to do is you have to utilize this current machine that is running Docker using the 5000 port of this machine and consume the 5000 port that has been defined inside the code base. So by default, Flask built-in port is 5000. And then I'm saying again, my web application will be running this port 5000. Now you have to use my machine's 5000 to run this app. You got the definition here, right?
Yeah.
Yeah.
So it's source port and then the target port and then the image.
Exactly. Yes. Perfect. So yeah, I believe you might have aware of these things. So yeah, the target port here. So now I can run this Flask app instead of local machine. This has been serving from my bundled Docker image. Now I don't need to install this Flask. I don't need to install these dependencies, which would be bothered my existing environment. I can have it as a separate working thing, which won't bother all the installations that has been done. Now we have one image. So like I said, for Kubernetes, we need to orchestrate all the applications. What is the applications are? Containerized applications. So what is containerized applications? At the end of the day, instead of a normal web app, we will be using a tool called Docker and bundle all our packages so that we can deploy and make use of a tool like Kubernetes to orchestrate it. Since we have bundled our images, now we are somehow aware of what images are. Now we need to orchestrate it with Kubernetes. Let me close this container first, else it will be running forever. Bother the port is with Docker PS. Okay, not the images are running. Okay. So right now we have our first image, which we have built it, and then we've ran it as well. Now this is where your answer for your previous question, like, can we install a tool like Kubernetes on a local machine? No, we can't. It is like a gigantic tool. It's like a mammoth one. We can't install a tool like Kubernetes so that we can practice straight away. Like I said, Kubernetes are for complex web applications with many microservices where you need to define several clusters. You need to have worker nodes, master nodes, and all those steps, which a normal in a normal machine we can't do that. So from Kubernetes, they have several utilities if you want to use Kubernetes on a local machine and play along with it. Okay, so lots of toys we are going to use. Lots of toys are there, and we are going to use this particular toy called Minikube. At the end of the day, all these toys will create a single cluster, single node cluster, where you can use all the Kubernetes based commands inside it. So we have to install this tool called Minikube, which will mimic the Kubernetes environment inside our local machine. This is Minikube's official site. We have to install Minikube so that we can play around with all the Kubernetes command inside. So Kubernetes is, you got it right. Kubernetes is not like a package where you can install with the sudo apt and then you can hands-on straight away. It is a tool, and this tool can be accessible only on highly reliable cloud environments. If you want to get familiarized with the concept, then you can use these toys. So one of a toy which we are going to use is Minikube. So this will do all the work for us. Okay, we have to install this. Now we have built an image and we ran it. It is successfully running. Now we need to import these image into the Kubernetes environment. So for that, so that we can orchestrate with it. So first, let's do our first toy orchestration with Minikube. So before getting things with Kubernetes, there are a lot of components as a part of Kubernetes, which we need to be aware of, like config map, services, deployment, stateful sets. What is there? A hell lot of things are there. If you are using databases, then it needs to be as this particular utility called stateful set, and there are some necessities behind that. So we will see about that as time moves on. For now, we need to be aware of, okay, if someone needs to know about Kubernetes, then there are several components has been as a part of it. And for now, we are going to stick with these two components called deployments and services. So what exactly deployment is? We are having one image and we need to deploy that. Fine, perfect. What is a service? So the deployed image needs to be accessed, right? So you can treat this as like this. For accessing this image, we need to run this docker run -p, right? So instead of running this command, we need to have certain definitions as a part of Kubernetes, and that definition would be the service here. So the deployment is used to deploy the Docker image, and to access my deployed Docker image, I have to do certain definitions as a part of it. And those definitions would come under services. So in layman's term, I would say consider this deployment as the vehicle which these packers and movers guy brought along with them, so that our application will be packaged, and we are going to use deployment to deploy that. And how are we going to access it? How are we going? When we are saying access, we need to unpack these things into a new house. So this new house is a service where we can get access to the things that has been unpacked from our old house. So again, similar to Docker, we need to be aware of several kubectl commands. So in Kubernetes, everything is a YAML file at the end of the day. All the definitions are YAML file at the end of the day. Similar to the Docker file which we saw. In Docker, all the definitions should be treated as, Docker file. Similar to that in Kubernetes, we would be having all the YAML files over here. So the kubectl is one command line utility which we need to install as a part of it. Like I said, you can access this kubectl command on AWS or GCP straight away the moment you enable the service, but you can't install this kubectl command straight away on your local machine. Once you're done installing Minikube, you can install kubectl so that you can play along with it. Now, I'm having this image as a separate thing. I need to implement this into Kubernetes. So for that, like we saw, hell lot of components are there, which we are not going to bother about as of now. We are going to take two things. One is deployment and one is service. What is deployment? What is service? Again, we don't know. Let me put it, let's go with the flow. We don't need to bother about that. To deploy our image, we need one utility called deployment, and to access our image, we need this utility called services. So let me open the Kubernetes definitions for it. Like I said, I have one directory called toy orchestrations where I have all the definitions inside it. One is my deployment definition, and the second one is my service definitions. Let me open this here. So like I said, at the end of the day, all these Kubernetes based things are YAML file. But again, you need not to define a YAML file if you want to deploy your app. You can straight away use kubectl command and use the images straight away. Instead, this is like we would be running bash script, right, for all the automation tasks. So these YAML files are like avoiding unnecessary chaos, because every time I can't use this kubectl command and run all these things. So I'm having one YAML file, and I would be make use of this kubectl command to consume this thing. So what exactly happening here is, there are several versions of Kubernetes versions would be there. So what I'm saying here is API version of apps slash version 1 is the version name for me, and then my kind is deployment. So kind is the Kubernetes based definition to define what type of component you are going to use. I'm going to use deployment here. So I'm defining, hey, pick up this thing called deployment as this particular YAML files kind, and leave this metadata label stuff. I'm just giving name for my deployment. My deployment name should be toy-flask. And again, it should be one replicas. Like I said, one of the huge advantage of having Kubernetes is auto scaling factor would be working in a steroid mode. In typical application, what would we do if we want to scale up our application?
We basically deploy it on multiple servers and then cluster them.
Exactly. So suppose I need to scale it. Like I have resource which could serve thousands of users, and next day my app became a big hit and millions of users were there. Now I need to either do a horizontal scaling or vertical scaling at that time of the day. Behind the scenes, I need to reconfigure the instance capacity so that it could handle it. I need to create replicas. So instead of doing this, all I have to do is there is some definition in Kubernetes called replicas. I have to define the replica sets. If I gave 2, then this particular resource will be auto scaled to 2. It's like huge work that has been reduced into a tiny thing by writing one line of definitions. I don't need to go to my cloud provider and then I have to redefine all these things. I don't need to do horizontal scaling, vertical scaling. All I have to do is I have to define this one particular set called replica sets. And this will do the work for me. We will see about these replica sets in a separate session. So leave these blah blah things, which is complete chaos, which we need to be, we don't need to bother about as of now. These things are apps and names, if you put it this way. This is the most important thing. So my container is here, which is my image is here. This is where I'm defining, hey, use this Kubernetes utility called deployment and implement this image. So this is where the connectivity getting in touch between the image which we built and the Kubernetes tool which we are going to use. The image pull policy is one definition which could be used to pull or push the images from the bucket. So typically we don't have these Docker images on our local machine, right? So we would be we would enable the CI/CD process for it, and then on our repository. And then from there we would be pushing it to some buckets at the end of the day. It could be AWS S3 bucket, it could be a GCP GCR bucket, or Azure Blob Storage. And then from there I have to pull my image. So Normally for pulling the image, there is one Docker command called docker pull, and then you have to define the image definition for it. If you are having access to it, because if you put it your, if you have, like you asked, you can have your customized image, and then if you're putting it on Docker Hub, you have to use docker pull command to get the image from there. But for production images, we can't give public access to it, right? So we have to be define certain artifactories. There are a lot of artifactories out there. JFrog is there, exclusively for image archives, or these S3 buckets, which is a normal storages for AWS, which could be used across, can be used to serve the images as well. So I can put all these images on a cloud, and then I can pull it from here by using this image pull policy. How this would happen is, right now my mission is my image is in local environment, right? So
Mhm.
I have simply given the name of my image. Suppose I want to pull this image, which is Docker pull at the end of the day, from some private archive, like my client has their production images on a JFrog, then I have to pull it. I can't do this Docker pull command every time. So what I'm going to do is, on the image definition, if you are using JFrog, there they will give you a link. If you want to access this image, then use this link. I have to paste this link over here, and then I have to have my secret. There is one utility called secret, which will work as an authentication. Like it is like a password authentication. For public image, you don't need a password, but for private archives, you need password. So to access private archives, we need this thing called secrets. So the image pull policy is about that. What I'm saying here is, hey, don't pull this image called simple flash cap from anywhere, because it is already in my local machine. You don't need to do that. Don't do that. Never. If I want to pull it every time, then I have to use some other command and arguments for this. And then I'm putting a name for this particular deployment called toy flask, and I'm saying this port will be 5010. So these port definitions has not been defined on our flask cap. So technically we can't access this, but we can create this other. We can create these things. So I'm saying the container port is 5010. Can you get what this line might supposed to be? Can you get a glimpse about what this meant? The name itself would give you some idea about what this port might be.
So instead of 5,000, it will on this particular instance it will run on 5010 port.
Yeah, it is not about this instance. I am having one image, and that image would be exposed to some port, right? I am making the definition here.
Yeah, no, but see, one question I have in here is, right.
Mm-hmm.
So you're using Kubernetes to orchestrate, right? But you're only putting like one image out there, right?
Yeah,
So one
yeah.
image is running one instance. Doesn't Kubernetes ask you to have more than one?
For one more than one image, you need to create separate YAML files for it. So separate definitions for it. You
Right, but
can't. Mm.
you're trying to you see. I think the orchestration um, concept
There is,
is
there is not a tool. There is not stick protocols on Kubernetes. Like if you're using only one image, then it won't work. It's not like that. There is not a definition there. You can still use one image. You can orchestrate with it. Technically,
okay,
that is not a feasible solution to a tool like Kubernetes. For
right? I
practicing, we
mean,
are just using one image.
yeah, so you could use Docker itself, right? I mean,
Exactly. Yes. Yes. Exactly. Yeah. Why would I need a Kubernetes if I'm having a single image?
yeah.
Mhm. So
So, so
I'm saying,
in this
mm,
case, right? If you have if I want to run like multiple instances, right? I'll say
Yeah,
replicas equal to 2, and then for the
yeah.
second one, I'll say container port. I can use a different port if I want.
No, that's what I'm correcting here. Your understanding of container port is wrong. If I'm not wrong, you have understood. Hey, this instance is running on a cluster. Then use this port. That's what you're
Right.
understanding, right? That is not. No, your understanding is wrong. What I'm saying here is, hey, I am having an image, and this image have the capability of exposed one port, and I have to make use of this port so that I can uh, access my resource using Kubernetes. But I need to be aware of the containers port.
Okay. So this is not the application port, but this is the container port.
Exactly. Yes, this is my applications port and not about this instance port. I'm not defining here. Okay, while running it, open this port called 5010. It won't work that way. What I'm saying here is I'm having one image and that image can be accessible only with 5010 because
5010.
that's how the
Okay.
image has been built. And I'm telling, hey, don't use any other ports because the container port is 5010, so you can't access it. So that's what this definition supports. It is not, this definition is not about using 5010 for this created deployment. This definition is about using 5010 port. I have to use 5010 port because this is the only way I can access this image called simple flask app.
Okay.
Yeah. So now I have defined the container port. This is our vehicle has been ready along with the image, which is our bundle. Now to access it, I have to use this Kubernetes component called service. And again, similar to this definition, we have to create this as well. So the API version is v1 and my kind is service. What I'm saying here is, hey,
Mhm.
treat this YAML file as of kind service
Service. Okay.
and leave this blah blah because I'm just tagging some names for my service, which is of toy flask. And on the specs section, I am defining this type as a node port. Now, inside the node port, I am saying port for this particular service, which will be attached to this deployment, will be 5010 because on the deployment, it has been defined as 5010 because the simple flask app can only be accessed with 5000. Now, to access it on the local node port, then use this port. So I'm making a connectivity here. I'm
Okay.
making connectivity saying, hey, use this particular node, which is this machine for now. If it is on the cloud, then suppose you are having a complex application, then you need to create 3 nodes. Then each node would be having separate port. And there you can define which node port can be consumed along with it. So the target port here is 5010. So this is literally this definition, but in Kubernetes way. The
Mhm.
container image port is 5010, but the created Kubernetes cluster node would be 3010. So this is literally this way of doing this definition. So the node
Okay.
port would be 31150. So now for creating this, we have to be aware of a lot of commands. But before diving into this, we need to be aware of 2 things. One is we need to start our minikube tool. Did we did that? To check the status of it, you can use minikube status. So it is not working. Minikube, we just stopped just now so that the Docker container won't bother. See, right now, let me tell you one more thing. So this is our local image directory, right? We just built
Mhm.
this image few minutes before. Now, to make use of Minikube, you need to have this image inside Minikube's daemon instead of the normal Docker daemon. So that's where the error we got at the initially, because I've been running minikube daemon. Minikube would be trying to access the Docker, and the Docker would kubectl AP would be trying to access one port, and then the Docker would be accessing one port, and that's where mismatch happened. So first thing is, this is my Docker image ls, and please make note of all these images, because once we went inside minikube daemon, the image list would be different, because these two are separate environment. This is my local environments image. Now I am going to start minikube using this command. So minikube start driver docker Kubernetes command over here. So to create a deployment, first thing is I need to go inside minikube's daemon. So for this I have to eval into it. I'm saying, hey, go inside the minikube daemon instead of the normal Docker environment. Now the moment, see, this is the normal Docker directory list out. Now the moment I went inside minikube environment, now I'm inside minikube environment. Now if I do the Docker image ls, it is some other thing. You got it right. Additional Kubernetes built-in images are here. So these are two daemon inside my machine. So while you are making use of minikube, instead of locally building your image, you have to go inside minikube's daemon, and then inside this, again you have to do the Docker build command and build your image over here. So now simple flash cap is the same bundle which we have over here, but these two images are not in a separate, are not in the same environment. These are in separate environment. So okay, don't make things complicated. I'm having one image. To run it, I will use docker run command. Now I'm going to use Kubernetes. So for that I'm going to use minikube, and if I'm using a minikube, then all the images that needs to be inside the minikube's daemon. So for that I'm going to use this command called eval, and then again I have to build all the images so that I can play along with my Kubernetes resources. So I have two components over here. How I can create this? So to creating this, either way you can do two ways. One is by normal state away definitions, or you can have it as a YAML file, and then you can apply the YAML file to the kubectl command. So before that, you have to create a namespace for your cluster. These namespaces are like separate compartments. How to say? Suppose you have created one cluster. You don't need to use a single cluster for only one application. There are multiple applications would be there, and all the separate applications should be comes under separate namespace. So this is like while we are installing a OS, we would be do the disk partition, right? We would define, hey, the hard disk is of 2 GB size. Make it as into 4 things with definition C, D, E, F, so that I can make use of it. In similar way, Kubernetes have this utility called namespace, where you can have all your resources on a separate namespace, all your web application on a separate namespace, so that you can run independent applications on a single cluster. So I need to create a namespace. So for creating a namespace, I have to use this tool called kubectl create namespace. We can have some namespace. So toy namespace. Okay, my namespace has been created. So kubectl. So create, get are the two command line utilities along with the kubectl command, which we know as of now. What I'm saying here is this combination can be used along with anything. Right now, I want to create namespace, so I have used namespace. If I want to create deployment, I have to use create deployment. This is like a puzzle like jumbo words. The command would be similar, but based on the resource, it would be vary. So what I'm saying here is list out all the namespace that has been inside the machine. So these things are built-in namespace. This is for my I can't reveal those things. So this is toy namespace that we just created just now, and its age is just 7 seconds. So we have one namespace on our single node cluster. Now inside this namespace only I have to define all the resources. In that way, suppose I want to use the same minikube and I want to create resources for separate web application. The moment I type my kubectl get command, it should not list out all the resources. Instead of that, it should list out only the image or resources that has been needed for me. So I'm going to create my deployment and service inside this particular namespace. So for that, what I'm saying here is, hey, kubectl, apply this YAML file, which will be in the current directory, and put it inside this namespace called toy namespace, which I have created a moment before. You got it, right?
Yeah, but I'm trying to understand. So where is your Docker image coming from?
Yeah, my Docker image is inside my minikube daemon. Here
And
it is. My Docker
already
image
moved.
is. So usually, don't make things complex. Usually we pull from bucket, right, for the production image.
Mm-hmm.
So for the production image, our definition for deployment should be some other thing. But since we are using our local image, we are simply give the name of our application. And
Okay.
if the image is not here, this deployment will throw an error. The defined image is not here. So
Right, but
that's how. Yeah.
no, I was thinking. See, you have a Docker image.
Yeah.
How did your Docker image get into kubectl? Because
Yeah,
both
that's
are
why
running locally.
the I'm bringing that images into Kubernetes by creating this resource called deployment.
Okay.
The moment I create this deployment, I brought this Docker image into the Kubernetes based environment.
Okay.
That's how the connectivity happening. So I need to create this. So what I'm saying here is, hey, I have one YAML file at the end of the day. Okay, that YAML file have the kind of what type of resource which I need to use. What you have to do now is create this particular YAML file which have certain blah blah definitions inside the namespace which I just created few minutes before. So kubectl apply of point namespace is the namespace which we created, and then so our deployment has been created. So to list out the deployment similar to the namespace, we can use git command. So kubectl get deployment, because any idea why it is not listing out the deployment which we created?
Because it's not in the local directory.
Because I haven't given a namespace for it.
Okay.
So
Yep.
if you're not giving a namespace, it will by default take the default namespace. So while we are creating the deployment resource, what we have set to the Kubernetes tool is make sure you have to create this resource inside this namespace.
Namespace. Mhm.
So now I have to define, okay, I know it wouldn't be default namespace. So what you have to do is get the deployment, get all the deployment that has been inside this namespace called toy namespace. Perfect. Now one resource is there. Any idea what is this toy flask mice supposed to be?
It's supposed to be the Docker image name.
No, this is the deployment name which we have defined over here.
Okay.
So our deployment has been created in the name toy flask, and it is running perfectly because 1/1 is the ready state of a image. there are several built-in errors will be there. The image, if your image is not here, then it won't work. Let me delete this. kubectl delete deployment. kubectl. So similar to get, I have used this command line utility called delete. This will delete the resource which is deployment of name toy flask. Why I did this? I just want to let you know about what would happen. I just want to let you know about how the connectivity between the image and Kubernetes is happening. Like you asked, how I'm bringing that image into my Kubernetes environment. So here, instead of
Yep.
simple flask one, I'm adding some other thing here. Okay. Now, do we have the some other thing over here?
No.
Do we have the image over here? No. Now I'm going to create. Okay. The deployment has been created. Let's check this deployment. Can you see the state here?
No, it's not ready.
Yeah, it's not ready because the image is not there. This is where the connectivity between the Kubernetes and the image is happening.
Okay.
So you brought into the Kubernetes environment by having this definition called deployment. And inside the deployment, you have defined, hey, in my machine or in some remote bucket, there will be an image. If it is not in my local machine, pull it. If it is a private one, then use the secret, which we are not know as of now. For now, just check whether this image is inside my local machine or not. If it is there, the state will be 1 by 1. Since it is not here, the state is 0/1. So let me use the name of our application. Now I have to delete this resource again, and I have to recreate this again. Now I have to get the resource. Perfect. Now it is in ready stage. The age is 3 seconds. So this is where the connectivity happens. So now, similar to this, you have to create your service resource as well. So the toy service is here. I have to create this. Similar to this, I have to tell the YAML file which needs to be installed inside toy namespace of type service. Okay, so what it's saying is the service toy flask is invalid. This is one built-in exception. Set.port0.node port. Invalid value 31150. Provided port is already allocated. So the error is pretty clear because already some other service has been making use of this port. So what we have to do is we have to change this to some other thing. So I'm changing the port node port to 57 instead of 50. Now let me recreate this again. Perfect. Now it's working because our error is pretty obvious. Already a service is making use of 71150 on my local machine, and since I can't make use of it, now our service has been created. So kubectl get service hyphen namespace equal to toy namespace. So all the definitions are here. Leave the cluster IP, which we don't even know as of now. Leave the external IP. We have three definitions on our service.yaml file. One, the name. Of course, we have given a name for our service. 2 of type node port. 3, if it is a node port, then use this 31157 because 31150 has been already occupied. And that's what listing it over here. So we just created a deployment and one services by using the image. So to access it, we have to be aware of the container port and the Docker file that needs to be tweaked in such a way so that it could use. And we have to aware of one more resource called ingress, which we don't cover as a part of this one. So conclusion is similar to this way of accessing it, we have to add this port. Since our Docker image is not in that stage, we are not going to do that. If we do this one, it should work if our image has been exposed in a proper way. So that's what for accessing our local machine with this node port, we are doing these many things. And the moment we use this, it won't. This is like a IP based access, which we don't usually use on the production environment. So how we usually do the reverse proxy for a web app? We use load balancers, right?
Yeah.
Yeah, we use Nginx, or a lot of load balancers are there. Nginx is there, traffic is there, a lot of load balancers are there.
Five.
So yeah, so instead of that, there is one thing called ingress, which we see about that later. The moment we define the ingress, we can access this as a part of a domain name instead of IP address based thing. So that's what this introduction to Kubernetes is all about. So just a small glimpse. Kubernetes is an orchestrated tool. For orchestrating, we need to be aware of Docker, which is packing our application. So how to pack our application? Using this tool called Docker. How we are going to run run our packaged image? We need to build an image, and then we have to use some commands to run it. So for building an image and running an image, we need to be aware of certain commands, which we did that. Now, to broad these terminologies or technologies inside Kubernetes, we have to create a cluster. So creating a cluster is not feasible in a local machine. So Kubernetes just provides several toys. And one of the toy which we used is Minikube. Inside the Minikube, to consume the image which we built using the Docker file, we have defined two things. One is deployment. The deployment will make the connectivity between the image and the Kubernetes. The moment I mention the image name on this Kubernetes YAML file, I brought that image into my Kubernetes environment. And then to consume it, we have to use service.